Everybody's in. It's just after 7 o'clock, March 24th. Thank you all for attending tonight. Looking forward to another conservation webinar. We've got Dr. Jen Barron. We've been going back and forth for quite some time, I think probably the better part of a year, trying to get some of her time. She's super busy, and now we have her. So the conservation webinar series is something that the BCWF has been doing for probably around 3 years, something like that. And where we have topics that are interesting to our members, interesting to the public. This is information. Dr. Barron's a researcher. She is not an elected official, so the process will be she'll give a presentation somewhere 40 to 45 minutes. As we go, feel free to add questions in the chat. If you're on Zoom, if you're on Facebook Live, just add them in the comments, and we will aggregate the questions. And then once she's done her presentation, we will ask questions. And of course, in her world, some policy questions she'll probably take on and some she won't. I'll remind everyone that she's not an elected official, so if you feel your blood pressure rise, you can feel free to contact your MLA to let them know how the way you think things should be done. So in this webinar, Dr. Barron will cover the historical context of active fire regimes, their disruption throughout the 20th century, the consequences for fuels and forest structure, and how landscape level management can restore fire as a process. Impacts on wildlife and habitat will also be covered, and then at the end we'll have the Q&A session. About Dr. Barron, Dr. Jen Barron is a postdoctoral research fellow and incoming assistant prof in fire ecology at the Center for Wildfire Coexistence, which is at UBC Okanagan. So really fortunate to have that position. She completed her PhD at the UBC Faculty of Forestry, where she focused on understanding and managing altered fire regimes in southeastern BC. Through her research, she works to understand how the ongoing legacies of colonial land management systems have altered the fire regimes and how the strategic applications of treatments and management can restore fire-adapted communities, ecosystems, and landscape. So she's going to give us the background, she's going to give us where we are today, and then what we can do to mitigate or at least adapt some land use management practices to take care of our forests, to take care of our infrastructure like our houses, and help wildlife all at the same time, I guess. So Dr. Barron, thank you very much for coming on. It's all yours.
Great, awesome. Thanks, Jesse. Thanks for having me. And yeah, I'm glad we can make this work. You guys first reached out to me about this probably over a year ago, and it took some time to set it up. So I'm glad we could get something done. So yeah, today I'm going to talk a little bit about past, present, and future, and take us through a story of how we've gotten to where we are today, and then also what that means for the values that we care about on the landscape, and especially for wildlife. So before I get into it, I want to acknowledge that the University of British Columbia, Vancouver, where I did much of this research, is located on the traditional, ancestral, and unceded territory of the Musqueam people. But my research program, largely in southeastern British Columbia, is on the territory of the Tanaka and Secwepemc people, who have stewarded this landscape and fire since time immemorial. So a little bit more about me and what I do and what I study. I'm currently a postdoctoral researcher, and I'm currently setting up this research program as a professor at UBC Okanagan, where I study fire regimes and fire-adapted ecosystems. So I'm a fire person, but I'm also more broadly an ecologist, and I'm very interested in the relationships and processes in these ecosystems that have some type of historical fire component, and their management today for a range of values. I also have experience working as a fire practitioner to some extent, so I spent several years working on prescribed fires, largely in southeastern British Columbia as well, with municipalities and First Nations. And a lot of this has also formed my perspective on land management and how my research can inform practice. So these are some news clippings of fire in the news. I often get asked whether fire seasons are actually getting worse. Many of these headlines have become much more common in recent years, and I would say also from our perspective in universities, we've really seen increased pressure and requests by the media. 2023 was by far the worst fire season I've ever experienced, especially in terms of the number of media requests that we got and were asked to manage at the university level. one of the questions that comes up a lot is fire actually getting worse? And this is one of the things that I think about a lot from a research perspective over longer time periods. So this map shows all of the fires that we have on record in British Columbia. We have one of the longest fire history records of modern fire activity in the country. So our records go back to the early 1900s. Essentially, as long as we've been putting out fires, we've been keeping track of where we've been putting them out. And so across the province, through most of the 20th century, fire was relatively quiet. And this was for a range of reasons. In part, our fire suppression systems were very successful for a large portion of the 20th century, also periods of cooler and wetter climate. And we do see over the past 5 or so years that fires are getting more frequent, larger, and more severe. So 2023 was the most expensive and destructive fire season on record, but in 2017, 2018, 2021, 2023, and 2024, wildfire seasons consecutively broke records and collectively burned over 6 million hectares, or 10% of the province's forested area. And this has unprecedented impacts not only to our ecosystems, but also to our human communities and the way that we interact with these ecosystems. So the extensive and increasing social and ecological impacts of these wildfires have repeatedly demonstrated that our ecosystems, our infrastructure, and our communities are not resilient to wildfire in their current state. So this pie chart shows the 10 largest fire seasons that we have since we've been keeping these records from the early 1900s. And so you can see of those 10 fire seasons, of the past 5 years, 4 of them have occurred. So 2017, 2018, 2021, and 2023 were all very large fire seasons by area burned. And I will say, just because a fire season is large or a fire event is large does not necessarily mean it has the most impacts. This is just one way to measure the impacts of fires. Another way to look at it is fire severity, or the number of evacuations, or the number of insured or uninsured losses. But this is one metric that we often use to characterize impacts. And of the largest fire events in our province's history, 5 of them occurred during the 2023 fire season. And so we really are seeing an increase in area burned and fire impacts today relative to the time period of post-colonial fire management from the early 1900s to present. But if we rewind to the early 1900s, we'll find that our ecosystems were very different then than they were today. So over the past 150 years or so, we've seen these landscape level shifts in fire regimes and ecosystems. And this picture is from southeastern BC. It's overlooking the K2 Ranch near Invermere, where a lot of my work takes place, but we see many of these similar trends across our dry ecosystems in interior British Columbia. So on the left, we have a picture from the early 1900s, from 1906. And on the right, we have this image that was retaken in 2018. And we see broad changes across these landscapes at the low elevation valley bottom, but also in our more montane mixed conifer forests. And the biggest thing that we often see in these pictures is more trees. So not only are there higher densities of trees across our landscapes, but the compositions of these trees have changed. And this is playing a large part in what's driving these changing fire regimes in combination with an increasingly warming climate. If we think a little bit about what's happened over this time period, here's an image from the BC Forest Service. This is at Labor Day in Invermere in 1949. And here they're telling us that fires destroy game, and so we should prevent forest fires to keep our forests green. And this is what a lot of those ecosystems look like today as a consequence of those land management decisions. And so what I try to think about through my research is not only how are things today relative to the past, but what are the decisions we've made through the 20th century that got us there, and how are those decisions continuing to influence our management today? So we know BC's ecosystems are very diverse, in large part because of the rugged terrain of the province, the number of mountain ranges, and the creation of these distinct climatic zones. We get very diverse and unique separated ecosystems that all have a fire component in them historically, whether that was very frequent low severity fire or less frequent higher severity fire. all of these ecosystems, to some extent or another, are adapted to a level of fire activity. And so, in one of these studies that we've done, what we looked at is in different ecosystem types, what is the type of fire they're adapted to based on fire history reconstructions that were done with tree rings, and where are they at today relative to that fire activity. So in southeastern BC and in many of our dry interior forests, the driest, lowest elevation and warmest climates are adapted to the most frequent fire regimes where fires burn very often, every couple years, at very low severity, meaning they kill very few trees. Our higher elevation, colder systems are adapted to less frequent fire, but when fire does occur, when it's warm enough for fires to occur, it occurs at higher severity, killing the majority of the trees present. And many of our more mesic or mixed conifer montane forests are adapted to a combination of this low and mixed and also moderate severity fire that occurs at various time intervals and at various severities. We also know from these fire history records that these fires were happening too frequently to be caused by lightning alone. And so, in combination with Indigenous oral histories, our understanding of this is that these historical fire regimes were created and maintained by Indigenous land stewardship systems that maintained the ecosystems and the relationship between fire and plants and vegetation and animals. So this picture on the left is from Greg Green's PhD thesis, where he reconstructed fire history in the low elevation valley bottom in the southeast. This is the North American record for the number of fire scars in a ponderosa pine. So when a fire occurs at low severity, it scars a tree or it damages it, but it doesn't kill it, and that tree continues to grow around. And this is also one of the ways that we can reconstruct fire history in these ecosystems. So this specific ponderosa pine, which is a sample that was collected near Tobacco Plains in southeastern BC, near the US border, it survived and burned 52 times in its lifetime. And so this is the North American record for the number of fire scars that we're aware of in a ponderosa pine. And this is right next to Tobacco Plains, where we know that Ktunaxa people were burning frequently, likely for the cultivation of tobacco as a medicine plant. We also know from these records that fire regime disruption first began with colonization. So this picture on the left is from the residential school at Accom First Nation, St. Eugene Residential School. We know that traditionally these landscapes were tended in a seasonal round with fire, with burning happening in the spring and fall, times to burn, times where fuels were mitigated on the landscape in the winter, and times where plants that were fire adapted and animals that made use of those fire adapted landscapes were harvested in the summer. And so the seasonal round reduced the severity of frequency of fires when they occur. And we also see this more broadly across North America. So this is a map depicting the year of land use transitions with influences of fire regimes linked to tree rings, where we see that as European colonization progressed across Western North America, fire regimes were disrupted at different periods of time, increasingly towards present. So in one of these studies that we did, we mapped these fire history reconstructions, one of which you can see on the left. So each of those horizontal lines is a different site, and each of those little vertical tick marks is a year where at least 2 trees at that site recorded fire. And so we find in these dry ecosystems in the past, fires occurred very frequently on 7 to 15-year averages. However, beginning in the late 1800s, and then particularly after the 1940s, we see a cessation of fire activity associated with colonization and fire suppression systems, where many of these ecosystems have gone 50 to 100 plus years without fire. We also know that fire played a role in all of these ecosystems in the past, and that it's been a long time since fire has been present in them. So in particular, in this study, we identified 3 different phases of fire regimes, or 3 different management and climate eras that we associated with different fire activity periods from both lightning and human ignitions. So a common misconception is also that fires have been inactive through most of the 20th century. During the early settlement period in the early 1910s, 1920s, and into the 30s, there was a warmer and drier climatic period, also associated with an early settlement era before fire suppression systems had been introduced, where large areas of the landscape were burning. And this was due to a combination of intentional and accidental ignitions resulting from settler use of fire to clear land for agriculture or for homesteads, the development of the railroad, where we often see in tree ring records the introduction of the railroad resulting in a higher number of ignitions, beginning when the railroad was first built and continuing to present, burning hill slopes to expose minerals and ore, and early machinery used in other resource extraction, including forestry. And so during this time period, a lot of the landscape was burning, but in very different ways than it did in the past, at different severities and managed in different ways. Beginning in the 1940s, we see a large drop-off in fire activity that's associated with the introduction of fire suppression systems at a time when our climate was cooler and wetter, which gave us several decades to develop those systems, including systems inherited from the Second World War, like aerial imagery and fixed-wing aircraft that allowed us to fight the war on wildfire, so to speak, and much of the information, dissemination, and propaganda that was developed during this time, so that when it became hotter and drier in the 70s and 80s and our systems were tested, there were few cases where fires escaped suppression. And this is really when we started to bolster these systems with more structured incident command system, heliTAC, and really secured these systems into our culture with this expectation that we would be able to put out all fires. The 2003 fire season in British Columbia was really a tipping point and a harbinger of things to come, so to speak, where after 2017 and 2018 repeat back-to-back fire seasons, we began to realize from a fire management perspective that we'd been deferring the impacts of these fires, but that our systems were not necessarily built to prevent all fires on the landscape. So the consequence of this, we often refer to in terms of fire deficits. And so what this concept means is the number of fires that are missing today relative to how often that ecosystem used to burn in the past. So this is a simple ratio of the historical fire return interval relative to the current time since fire. So say an ecosystem used to burn every 10 years and it hasn't burned in 100 years, it would have an interval departure of 10 or a deficit of 10, meaning 10 fires have been missed from that ecosystem. And this gives us a relatively easy to understand metric of the ecological context of what's missing from this ecosystem. So in this study, we found that there's large fire deficits across almost half of the landscape. Our submontane or our dry valley bottom ecosystems have missed 6 to 10 fires relative to their historical fire regimes, and our montane mixed conifer forests have also missed 1 to 6 fires. We found out the departures are greatest in historically low severity fire regimes. And the challenge with this across British Columbia is most of our river systems and most of our communities are built in these low elevation valley bottoms. And so these are the locations where the threat of wildfire is the highest and also where most of our values are concentrated. And so these deficits are essentially exposing communities and ecosystems to the threat of severe wildfire. So in terms of how this exposure works, in fire-adapted ecosystems, frequent fire removes fuel, but previous fires ensure that not a lot of fuel grows back in between fire return intervals. So essentially, a little bit of fuel grows, a natural or human-caused ignition occurs and removes some of that fuel. Most of the mature trees survive. In places where fire has been missing for over 10 fire return intervals, for example, trees continue to regenerate, compete with each other as they grow towards the canopy, and this results in increased fuel density and continuity, the creation of fuel ladders that can conduct fire from the surface up to the canopy, and altered species composition. And this does not occur in a vacuum as a result of fire suppression alone. The forest industry also has had a large role to play in these changes, including selective harvesting and then replanting less fire tolerant species that are favorable for merchantable timber, and increasing the continuity of fuels across the landscape. So the combination of fire exclusion and forest management have essentially homogenized the landscape, where in the past we had more of a mosaic of different forest types that were more or less conducive to fire. Today we have a continuous fuel matrix of conifers that are very fire susceptible. So these reconstructions are again from Greg Green's PhD thesis, where he reconstructed the composition and density of trees in the past from these tree ring records. So prior to colonization, we know that these ecosystems were more open forest. Uh, they would exist for anywhere between 7 and 15 years without a fire event, and then a fire would occur, would kill more of the younger and smaller trees, the small saplings, and the larger trees would survive. And this composition and structure persisted for over 800 years due to a combination of lightning ignitions and Indigenous fire stewardship, creating this kind of metastability on the landscape. After European colonization, a cohort would initiate either as a result of a large fire or high-grade harvesting, and it would persist. So essentially, because fire did not occur to clear out some of these smaller stems, densities increased substantially, as well as competition in these stands. And that leads us to where we are today across a lot of these landscapes, where we have thousands of stems per hectare in fairly non-productive forests that aren't necessarily meeting timber values and are posing wildfire risk. And this is what we often refer to as the fire suppression paradox. So essentially, in an effort to protect our forests from fire, we've made them increasingly vulnerable to not only fire, but also to the consequences of other disturbances like insects and drought. And one of the problems with this from a larger ecosystem perspective is also that wildlife co-evolved with the habitat created by historical fire regimes. So it's not, so to speak, that one type of fire is better or worse than the other, but typically these ecosystems evolve with relationships between fire, climate, and vegetation, where wildlife are responding to the types of vegetation that's created by historical disturbance regimes. So some examples of this include that fire both creates and removes snags and downed logs, which often serve as habitat for many species, including woodpeckers, which are often physiologically adapted to excavate and forage in recently fire-killed snags. And different species of birds often prefer different types of snags. So they've partitioned their niches, they've diversified their food source to identify either older snags or more newly created snags. Ecosystems with historically active fire regimes also often serve as reproductive habitats. So nest and snag structures are obvious reproductive habitat features, but this can also include large down logs that an elk calf can lay next to and hide from predators, or it might be dense patches of sagebrush that provide nesting cover for grouse, or seasonal wetlands that are critical for amphibians to lay their eggs. And it might also include cliffs and cliff ledges that can provide nesting platforms for raptors. Often discussed of importance, particularly in interior British Columbia, is wintering habitat, particularly for migratory species such as deer and elk or migratory birds. Oftentimes, winter is a limiting factor for individuals and populations, and scarce food resources or quality, cold weather, snow, and dramatic precipitation often make winter a very stressful time for a range of species. And then finally, security and hiding or thermal cover, which help animals avoid detection or create more desirable microhabitats, are all important features. And so this diversity of features that is created by more frequent but smaller fires is often essential for the wildlife that have evolved to make use of these ecosystems. And broadly, we can kind of characterize this as the diversity of overstory and understory vegetation structure and composition. So it's not that one forest type is necessarily better or worse for wildlife, but that we need this range of diversity of forest types to exist to support the diversity of species that are adapted to these ecosystems. This is a diagram from Eastern North America, but I like it because I think it does a good job of illustrating that diverse habitats are needed to support diverse wildlife populations. So typically these wildlife populations, birds are a great example of very specialized, often very specialized species, have evolved to make use of a specific ecosystem type at a specific successional stage and in its development. And so the range of these habitats helps support this diversity of species that we've become accustomed to and that we often care about from a conservation perspective. Okay, so now I'm going to go through and talk about some of the wildlife species that we associate with different types of habitats, as well as the fire regimes in these different ecosystems. So in our highest elevation alpine ecosystems in interior British Columbia, these are typically adapted to fairly infrequent fire that it can occur either at high severity, particularly when fires start at low elevation and burn uphill, or at lower severity when smaller fire events occur due to lightning ignitions. And so alpine zones are unique, and across the landscape, they're relatively rare. Vegetation can be sparse, and the fire regimes often vary depending on the starts and the ability of the fires to spread. Species that occupy these ecosystems are either migratory typically, or they're highly adapted to cold climates. And so some of our species in British Columbia that make use of these habitats include wolverine, Clark's nutcrackers, pikas, and grizzly bears. Moving down into subalpine forests, these forests are often adapted to more mixed or high severity fire regimes that can occur from anywhere from 35 to every 200 years. These are more abundant high elevation habitat types. Forests are often denser and have species mixes that are generally more susceptible to high severity fire events. The species that are present are often diverse and can include large ungulates such as elk, mule deer, and moose, as well as a variety of carnivores. And depending on the seral conditions and the fire history, a diversity of cavity excavator species. For example, woodpeckers will often take advantage of high severity fires in lodgepole pine forests, and lynx will forage in early seral lodgepole pine, which attracts snowshoe hares in the winter. Okay, moving further down, we get more into these mixed severity fire regimes that are adapted to a wider range of fire severities. So this can include forests with mixes of Douglas fir, lodgepole pine, ponderosa pine, and western larch. Species occupying these forests also often prefer denser forest canopies with more complex structure and larger continuous patch sizes. And some will also take advantage of the edge habitats that's created when more high severity forest patches butt up against unburned forest areas. So large woody debris and large decayed snags are often important habitat features, and species like owls, pine marten, and fisher, and pileated woodpeckers, as well as generalists like elk and mule deer, often thrive in these habitats. Another important ecosystem type that often is not discussed as often in British Columbia is aspen forests or broadleaf forests, or forests with a broadleaf component. So aspen in particular respond well to fire disturbance, and stand replacing fire regimes often enable aspen forests to persist on the landscape. However, fire suppression has often resulted in encroachment by conifers, and in British Columbia, aspen are actively excluded in the forest harvested land base through brushing and spraying by the forest industry as they're undesirable merchantable species. Ungulate browsing in these ecosystems is also important and sometimes a detrimental disturbance factor that affects aspen's expression and persistence, but many of our species in British Columbia are adapted to this forest type. Okay, moving down into our lower elevation, more open forest types. For example, our ponderosa pine and Douglas fir open ecosystems in the interior. These ecosystems are adapted to much more frequent fires occurring at lower or moderate severities every 0 to 35 years. So large old growth and mature ponderosa pine, which is widely spaced and shaped by frequent non-lethal fires, is often a dominant feature. However, this zone is one that's been most affected by the double whammy of past timber harvesting and fire suppression. In these historic conditions, stand and cover densities were often low, with trees that were large and snags and down woody debris few and far between, but often large and generally well decayed. Species utilizing this habitat include northern goshawk, Lewis and white-headed woodpeckers, bighorn sheep, American badger, plumulated owls, as well as habitat specialists such as elk and mule deer. And finally, moving into our low elevation grasslands, these ecosystems would have been maintained as grasslands, typically only with the persistence of frequent fires that remove regenerating trees. Many species of birds, including meadowlarks and Vesper sparrows, are familiar ground nesting birds of the open grasslands. but many more species use grasslands for at least part of their habitat needs. In addition, many small mammals use these ecosystems, including muskrats and marmots, and many bat species as well are found in grasslands and associated wetlands, cliffs, and canyons. These ecosystems also tend to be very important for pollinator species, which provide a range of ecosystem services because of the presence of flora or plants, flowering plant species that pollinators are uniquely adapted to. And so historically, collectively, the heterogeneity that was created by fires and created these ecosystems and other natural disturbances has historically limited the spread of contagious disturbances like fire, insect outbreaks, and disease epidemics, and maintain this type of metastability on the landscape. So this concept is that this pyrodiversity has created these diverse ecosystems that were enabled in the past. And so, kind of the biggest picture of all of this, from my perspective, as someone who does not specifically study wildlife, but thinks about the consequences of fire management for a range of ecosystem values, is that fire exclusion has created these really dense forests that aren't meeting objectives from a natural resource perspective, from timber management perspective, but it's also not doing much else in terms of wildlife habitat because there's no food in them for wildlife to eat. And so this is one of kind of the ways that I can distill it down to in the simplest way possible, is that this is not desirable habitat for very many species because no species evolved with this type of forest on the landscape. And when these forests do burn, they have more fuel than they did in the past, and they're burning under much hotter and drier conditions that they burned in the past. So they're burning at higher severity. And it's not to say that high severity fire is always bad. Many ecosystems evolved with high severity fire as a component, but many of our dry ecosystems did not evolve to burn at this level of severity with these types of fuel loads. And they are burning this way increasingly during recent fire seasons. And this has a number of consequences for wildlife as well. It impacts vegetation regeneration, it influences runoff into our lakes and rivers, it influences wildlife connectivity corridors and landscapes that are already heavily subdivided by human communities and natural resource extraction, as well as having an impact on our infrastructure. So from a mitigating fuels perspective, if fuels are a big piece of this puzzle, if fuels are part of the problem, what can we do to manage them and to reduce the severity of the next fire that occurs? Our goal in these approaches is generally to reduce fire from the ecosystem. Examples of fuel reduction treatments can include thinning, followed by removing the surface fuel that's left over, or prescribed or cultural or broadcast burning, or managed wildfire, allowing a wildfire to burn under more desirable conditions. What we generally try to avoid doing is rearranging those fuels. So that can look like thinning and then moving those fuels from the canopy to the surface, but not removing them. If a wildfire burns under these conditions, it can burn at very high severity because of the level of surface fuels that have been left as a result of the thinning. And the alternative to this continued status quo or continued fire suppression would result in the continued accumulation of fuels in these forests, and likely a fire burning at higher severity when a fire does eventually occur. However, although these treatments can help reduce the severity of the next fire, as an ecologist, I try to think beyond this suppression mindset. So although one of the perks or one of the benefits is that fuel reduction treatments can decrease subsequent fire severity, the ultimate goal of these treatments is not to increase our fire suppression effectiveness and control, at least from my perspective as an ecologist. The way I view it is that our goal is to reintroduce fire as a more stabilizing process so that we can allow these ecosystems to thrive with the variety of dynamics that occurred in the past and all of the attributes that different species and people rely on without having negative consequences to our human communities. And a big piece of this also involves the use of wildfire when it's safe and appropriate to do so. So this is from the wildfire management strategic plan, discussing this use of modified response wildfires, which we often use in a triaged approach when we have limited resources. There are also conditions where it makes sense to do so ecologically. And we do this quite a bit up in the northern part of the province, but I think increasingly we're also discussing its use case, particularly in the spring and fall or during more moderate fire seasons in the southern part of the province. And these are some examples of fires where you can see modified response was used and a fire was allowed to burn, perhaps with a perimeter, an allowable perimeter established and held under those conditions. And importantly, there's also growing recognition of the importance of Indigenous fire stewardship, including the authority and governance over land use. And from a historical perspective, restoring these fire regimes requires restoring the historical land-based relationships that created them in the past. And so from this perspective, excluding or appropriating those traditional management systems, for example, by integrating them into colonial land management systems, often reinforces the frameworks that resulted in their disruption in the past. And so this concept, which is often referred to also as two-eyed seeing or walking on two legs, is often brought forward, increasingly recognized as a pathway for restoration and reconciliation in these fire regimes, with Indigenous fire stewardship and Indigenous sovereignty at the forefront. And so collectively, this ecocultural restoration of fire and fire-adapted ecosystems looks like a number of things. It means removing some fuel from these ecosystems through mechanical and hand thinning treatments, and also finding use for that fuel in the bioeconomy, what to do with that leftover biomass that we don't currently have a market for in our timber harvesting model. It means increasing our use of prescribed and cultural fire, as well as pyrosilviculture and things like broadcast burning through the forest industry, and the use of managed wildfires. So allowing fires to burn when we can manage them and when they're not a threat, immediate threat to values, so that when we have those extreme fire seasons, there's less fuel in the landscape to be consumed. And then ongoing and continuing monitoring and adaptive management. We're in different climate systems than we were in the past. Our values are different, and so we're not necessarily looking to return to these historical fire regimes, but to use them as a reference point for where we might go in the future and to understand what our ecosystems are adapted to. And of course, there's constant questions about scaling. So different parts of the landscape have different types of values, and this has resulted in the presentation of a concept often called landscape fire management around how we manage for those values. For example, we might have areas where we want to protect an asset, areas where we might have potential revenue for timber harvesting, areas that are strategic anchors to prevent fire in the case of a wildfire ignition, and areas where we might have farther removal or lower risk to values where we can allow fires to naturally occur. And this requires strategic planning across jurisdictions and for diverse values. But the goal of this is that it should be guided by our understanding of fire as a process and processes in fire-adapted ecosystems. Where does fire want to go? Where is fire more likely to go? Where are resources best spent to prioritize management and reduce the negative consequences? In addition, most of our fire management in the province occurs by our provincial agencies, BC Wildfire Service, and indirectly through the forest industry. And so there's increasingly also discussions about how to involve the whole of society in wildfire management, including increasing capacity in people who are involved in managing the landscapes and changing the governance of who does that management. So this is animation of a prescribed burn association in Nebraska, where ranchers are burning to reduce encroachment. This is an example of a model that's been increasingly discussed also in British Columbia in terms of land manager buy-in into forest management or proactive fire management, and the role of different players at the table in managing these ecosystems. But from an ecology perspective, we still have a lot of questions about where to prioritize and what to restore to. So fire can be used in a range of ways to manage for a variety of things. That is a benefit, but it also requires a lot of decision making on the fire manager side of what we're managing for and what the goal of this treatment is. And from a restoration standpoint, fire on its own often is not enough. So do we need to do fire and invasive species treatment? Do we need to spray herbicides? Do we need to plant something? Do we need to do exclosures to prevent ungulates from grazing in here? There are a lot of unknowns in these systems to help us get to where we want to go. And so I'm just going to talk briefly about this habitat restoration project that we've begun with down at Tobacco Plains, where we know that forest thinning and prescribed fire are important restoration tools, but we also know they can create opportunities for invasive plants to proliferate, which complicates our management decisions. And so in this project, we're looking at the relationship between habitat restoration and invasive plant dynamics, with an emphasis on the need for Indigenous-led management interventions. So in particular, we're experimenting with a range of treatments, including mechanical thinning, prescribed fire, and wildfire, and looking at how this impacts invasive plants, forage, and wildlife response across different treatment intensities and timescales. In particular, we've identified cheatgrass in St. John's Port as invasive species of concern in treated areas that are posing challenges for native plant recovery and ungulate forage quality. And so in response, we're examining the efficacy of invasive species control measures such as herbicide applications and their trade-offs in wildlife habitat restoration. And the ultimate goal of this is for us to understand what the most effective and efficient way is to improve habitat for culturally important species of ungulates like mule deer, bighorn sheep, elk, and moose in these fire-adapted ecosystems that have been altered by fire suppression and the forest industry. And more broadly, the restoration of these fire-adapted ecosystems is challenged today by a number of factors that didn't exist in the past, including climate change, fire exclusion, and invasive species. And so this requires a present-day understanding of these ecosystems and their responses. But the consequences of the status quo we already know will result in a continued proliferation of these negative impacts. And so there's a huge need today to manage more proactively on these landscapes, and then to study the responses to understand whether we're accomplishing our goals or how to do so, how to help these ecosystems adapt into the future. Okay, and with that, I'm happy to take any questions. Thanks.
Awesome. Thank you. And you know what, Jen, I think this is a record. There isn't a question in the chat box at all. It's never happened. So all the participants that are online, if you have questions, please feel free. And I guess while we're on it, we'll just give a quick plug for Jen had a background in fire, so I decided to put one up on mine, and that was down at Little Chopaka, I think 2 weeks ago now. Maybe it was a week ago. I can't remember. Anyways, we worked on that burn for the better part of a year and a half, and we got 100 hectares burnt. So thanks to Lower Similkameen Indian Band, BC Parks, BC Wildfire, Environment Climate Change Canada. We talked to park staff. They said that was the first burn that they've got done since 2008, I believe, in the region. And it was literally like right across from, there's houses there, and there's a trailer park. And so it was just awesome to get everything pulled together in what was basically a year. So that was pretty exciting. So a big plug for everybody. All right, questions are coming in. Are you able to share titles, links to the research papers mentioned in the presentation? That we can probably do after the webinar, and we can also share that in our member update. Absolutely. Okay, here we go. I recognize this name, so this will be a good one. Can you expand on what's happening in the forests that have not yet departed from the historic fire regime?
Yeah, sure. So in that study, we could only evaluate departures in ecosystems that used to burn every 100 years or more frequent. And the reason for that is because we only have 100 years of modern records. So essentially, if it used to burn less frequently than every 100 years, it might be departed, but we don't know because we only have 100 years of recent records. So what's likely happening is that some of those more high severity ecosystems are departed. We just can't tell because we don't have a high enough modern spatial record. And in addition, even if a forest is within its historic fire return interval in terms of the time period, that doesn't mean it hasn't been affected by the impacts of the forest industry, climate change, and other drivers of change in those ecosystems. And so when a fire does burn in that ecosystem, even if it's within its historical return interval, it might be burning under hotter and drier weather conditions than it would have in the past. And that's going to result in a departure going into the future. And so I would say there's very few ecosystems in British Columbia that we would consider within their historical disturbance regimes. Many of those would also likely be either in the north, where we've had less impact of fire suppression, and also areas that are outside of the timber harvested land base with less impacts of natural resource extraction, or in some parks and protected areas where that have been established a long time ago. For example, Banff National Park, where fire has been allowed to burn across different ecosystem types throughout the 20th century. However, even those ecosystems are seeing indirect impacts from climate change and kind of the indirect consequences of our management systems. So I would say there's very few ecosystems that are within their historic disturbance regimes.
That's great. That's one of our struggles when we talk about some of the parks and protected areas, particularly in northern BC and in the boreal, where climate change is moving at, things are warming much quicker than down south. And so we're caught in this mind frame of this is, a 120-year fire return. It's like, okay, it's not now. So how do we get ahead of the curve and start thinking about what climate change means for a bunch of these ecosystems rather than sitting back? So yeah, great question, great answer. Here's another favorite. This always comes up when we talk about fire. Are some areas less suitable for salvage logging after fires? So do you maybe just want to introduce what salvage logging is so that everybody's up to speed, and then kind of talk about what it does and maybe how it could be improved?
Yeah, for sure. So salvage logging essentially aims to make use of the fiber that was burned, the trees that were burned during a wildfire that are potentially unlikely to survive, but are still merchantable timber, although less desirable in quality. And so this is often kind of very short-term response after a fire has happened when those trees are still standing, where licensees will go in and harvest whatever is left over. Salvage harvesting, pretty controversial, I would say, both from like a social and an ecological standpoint. There's been some research on the economic benefits of salvage harvesting and also the ecological consequences of salvage harvesting. In some cases, it can have benefits from like a broader term, longer term fuel reduction perspective. So when a high severity fire burns, typically, even if all those trees are dead, they're still standing and eventually they'll come down. And if you get another wildfire event happening while all those dead trees are on the ground, it is going to burn very hot and you are going to nuke the soil. And it's very likely that not much is going to come back. And so there are cases, certainly, where salvage harvesting can have benefits from a future wildfire risk reduction perspective. However, we also know that those ecosystems are very vulnerable and that remnant habitat is often very valuable for a range of species, including those snags that I was talking about for different wildlife species. And we know that having machinery in those ecosystems that have just burned often introduces invasive plants into the seed bank, and that has large consequences for the longer-term legacy of those ecosystems. So it's a complex topic. Certainly, it can be appropriate in different instances, but it really depends on the ecosystem, on the way that the fire burned, on where the fire burned, and also on where salvage harvesting fits into that management plan. What types of stems are they removing? What are they retaining? And then what's the mitigation measure to manage for the potential consequences of the additional disturbance in that ecosystem once it's already been disturbed?
Right. Yeah, because it's quite often the big stuff is the stuff that we want to see on the landscape for wildlife trees, and the small stuff is the stuff that gets left, which is kind of the opposite of what we would want, right?
Absolutely. Yeah. And I mean, that's also true even in thinning treatments. Wildfire risk reduction, forest thinning, there's often a trade-off in terms of they're very costly treatments. And so to offset the cost, they'll often also take larger stems in the prescription, but those are also usually the stems for ecosystem or habitat reasons that we want to retain. And so those treatments kind of exist on a spectrum of, are they more ecosystem restoration or are they more harvesting? And they can have benefits. I've seen it done well across both ends of the spectrum, but probably the worst case scenarios where we go in and take all of the large stems and leave all the tiny stuff that's very suppressed and kind of like those lower layer trees that's also very old and unlikely to have a growth release or provide quality habitat afterwards.
Awesome, thanks. This always comes up too. What's the low-hanging fruit to scale this up and do more? How do we do more?
Yeah, great question. I think we're essentially trying to scale a bunch of different things at the same time. In terms of the low-hanging fruit, I personally think those managed wildfires in the spring in particular and in the fall or during quieter fire seasons are something that we're not necessarily using to their full potential that we could be using. And to be fair, that's easy for me to say sitting from a researcher desk, not making those decisions in a fire center. There's always consequences of if we let it burn in the spring, could it pop back up to cause problems for us later in the summer? Same thing if we let it burn in the fall, could it overwinter cause problems for us the next year in the spring? But I do think there are a lot of cases, particularly in the spring, where fires are suppressed, for example, for to be used for training, where those fires could have actually done a lot of good. And I think there's a good middle ground in between a wildfire management response and a prescribed fire in those managed wildfire zones where we can develop prescriptions and potential identification of burn units and holding lines where we say, here's our prescription. If we get an ignition during a natural ignition during this prescription window, it's this range of temperature, winds coming from this direction, this type of relative humidity, we let it burn up to this line. So we essentially hold it as a wildfire as opposed to immediately killing it and putting it out. And it is easier to hold a larger fire than it is to fully put out a very small one. And so I think that this, from my perspective, I wouldn't necessarily call it low-hanging fruit, but I think it's in an area where we're not necessarily talking about it as much, not necessarily investing in it as much. We know that prescribed fire and cultural burning are things we need to be prioritizing. There's been a lot of attention provincially in prioritizing those values. Fuel management has been a priority for a long time, but of course, it's also very costly, thinning treatments. And so I think that opportunity and also opportunities where wildfire management aligns with other values and where funding can be aligned with other values. So it's not just a fuel reduction treatment, it's also a habitat management treatment or a water quality management treatment or a potential smoke and human health mitigation treatment. Opportunities where we can align multiple values and funding sources to get more of this work done where wildfire intersects with other things we care about on the landscape.
Awesome. Similar line of question. How would you suggest conservation land managers use this knowledge for managing areas for restoration? And what is the process for trying to return fire to the landscape, i.e. permits and all the rest of that? So this will be a long answer, but there's a lot to it. Go ahead.
Yeah, it's a great question. I think from a conservation perspective, the goal is to put fire back on the ground, but one fire is never going to return over 100 years of change, not just of fire, but all the other things these ecosystems are facing to the condition we want it. So we have to level our expectations in terms of what's possible. In many cases, the first fire is also very small and not necessarily reducing all the fuels we want it to reduce. We often burn, especially our first time logistically in terms of capacity, under more conservative conditions. So essentially, we're okay with it not necessarily being as severe as we wanted because people got out and they learned and we lit a fire and it didn't escape. And those are all good things. And the more we do it, the more confident we'll get and the better we'll get at it. And so often I think, particularly from a prescribed fire program perspective, the best thing you can do is just to try to get a fire on the ground. That's step number one. What you're really looking to build, what we're really looking to build across the province is programs, places where fires are used and reused as treatments. In many cases, forests are too dense to burn as they are. And so we have to first remove some of that fuel through thinning. But if we maintain it with fire, hopefully we won't need thinning again in the future and we continue to burn it on cycle through time. In terms of the permitting process and the approvals, it really depends where you are, whether you're on Crown land or private land or First Nation reserve land. And I will say also, although I've been involved in a lot of these burns, I'm not the one applying for the permits or going through the process. But typically, one of the biggest barriers that I find people face, especially with larger treatment areas, is aligning the funding with these programs. You'll get funding for different parts of the project. You'll fund the thinning and the burning from different ways. You'll fund different treatment units with different pots of money. And so often what you end up doing becomes dependent on where you got the money from and what that money is designed to do. I will say also from an ecosystem restoration perspective, the fire is not the end all be all. Relative to thinning, fire is cheap, but I do think that there's a huge need also for how we think about fire in our restoration plans and those other pieces I was talking about. So in a prescribed fire plan, for example, you might have a certain objective as a land manager of increasing forage for elk and increasing the number and the quality of elk. If you tell a prescribed fire manager that, they're not going to know what to do with that information. They need to know how to translate that in terms of consumption of woody fuels or consumption of grass, for example. Then you, from a conservation restoration perspective, need to know how to get from that stage to the variables that you care about for the elk. And so I think it's unfair to expect these prescribed fires and wildfire managers to be able to get us fully to our ecosystem end goal. We need to get better about how prescribed fire fits into our restoration management plan process and what pieces we need to fill in to get there. And that's a big piece of that project with Tobacco Plains, as well as understanding the role of fire in those management processes, and also in a place where harvesting is also happening and taking place, the economic trade-offs and incentives of those different approaches, and the cost. We don't know whether it's worth it to go in and spray or seed or fence different areas. And so that's a big part of the experimental treatment part of this, is trying to understand, we know these ecosystems burned in the past, but they did not have the extent of invasive grasses they do today. So we know if we burn, we're going to probably get invasives after. But if it burned in a wildfire, we would also likely get invasives after, and a whole suite of other problems. So now we have invasives. What do we do about them now that they're there? And are there things we can do before the fire or directly after the fire that influence our chance of success down the road?
Yeah, that's awesome. That is one of the, a lot of this stuff is really about trade-offs. Like, that's where we run into hard walls sometimes, is that sometimes there's parts of government or parts of society that don't want to face those trade-offs. And I think, you kind of hit the nail on the head. I will say, like, BC Wildfire now at one point was a challenge. They are off to the races. They're the biggest supporters. Even now, like, there's places where money is not the limitation, but quite often permits are. And that really is around the province prioritizing in some of the other ministries to say, hey, fire is a priority. Don't say no. Don't send something back 6 months. Say yes if. I think that's really where the political will needs to be, the pedal needs to be put to the metal, because there's a number of existing projects that have a lot of support from everyone, including communities that are leading it. And getting it over the line is the hard part right now with some of the ministries, and facing those trade-offs, like, yeah, we're going to have cheatgrass, but the alternative is, if we don't burn this, it's going to burn in August, and it's probably going to burn some people's houses down. So let's make the hard choice and do the proactive thing rather than sitting around waiting for it to be really bad. Here's one around air pollution. Can you speak to how to speak to an increased regime of managed fire on the landscape, how it will impact air pollution, if you know of mitigation efforts for those concerned about respiratory consequences?
Yeah, no, that's a great question. And it's a conversation I've had many times too with kind of air quality health experts, particularly Sarah Henderson, also from UBC. I think it's unfair to tell people that we're going to live in a world with no smoke. The past 100 years that we've become accustomed to with no fires on the landscape is not a future we can expect, even just with the impacts of climate change alone, the changes in fire regimes driven by climate change alone. One thing I can say certainly is that most prescribed fires produce far less smoke than a wildfire will. And because prescribed fires are planned with smoke consideration in mind, that smoke is also less persistent and dissipates much faster. That doesn't necessarily make that smoke less harmful, but it gives us more time to plan around that smoke, and it reduces the duration that smoke is present for. And so in areas where prescribed fire use is very common, for example, down in Florida, people have become accustomed to being inside on fire days. There's very good public information and messaging around the hazards of fire smoke, including increased use of air filtration systems or masks on days where there are prescribed fires burning. And I will say, when we have bad wildfire seasons where smoke is in the air for most of the summer, the consequences of that persistent chronic exposure are particularly detrimental. I'm not a human health researcher, but I can also say, even from my own personal experience, like, being in the field during bad fire seasons, you feel the consequences, and you certainly feel them much more so than one day where there's some smoke in the air from a prescribed fire. And it's easier for us to manage the smoke from a prescribed fire than it is for us to manage the smoke from a wildfire. So, I would certainly encourage people to look at the public information and health messaging that comes out including from the BC CDC around how to manage for smoke exposure, especially for vulnerable populations, for people that are immunocompromised or elderly, and kind of our broader societal approach to how we manage air pollution. But I don't think that prescribed fire is necessarily the problem. I think it is part of the solution, even though it will have smoke impacts on human health, certainly.
Yeah, again, there was a time where health authority was like a very big challenge to getting prescribed and cultural burns on the ground. Living where we do in the Okanagan, the reality is we can have controlled burns in the spring and fall, or we can have it so you have a half mile of visibility in the summer when they tell people, everyone, not just the people who are immunocompromised, don't leave your house. So again, this is a trade-off issue. Like, we can do this in a controlled way where yes, there are impacts, or we can let it rip in the summertime. And so I think as a society, those are the choices we're kind of facing. We've got one on from Facebook, and this might be, well, it's pretty close, slightly outside, but I think you've got this one. Reducing fuel loads, prescribed burning, cultural, Indigenous burning is great, but what are we doing to bring back the biodiversity in our trees? Get rid of monoculture and reintroduce a mosaic of species is what's needed. What can government do to legislate this type of forest management? Are we making progress on this? Have any thoughts on that?
Yeah, also a great question. I think a big opportunity for this is how we manage recent wildfire areas. We do have a lot of area that's burned in recent wildfires. Don't think we have a concrete strategy yet on what regeneration will look like. A large reason for that heterogeneity is not just the harvesting, but it's the replanting of monocultures. And so there is a huge opportunity there, particularly in recent wildfire areas, to evaluate those replanting strategies and or allow for natural regeneration of a broader range of species. In particular, I think broadleaf trees are a huge opportunity, and also a huge opportunity for cost saving in terms of the amount that's spent annually on reducing broadleaf trees on the landscape. In terms of whether we're making progress on that, I think it depends on where you look. In places where we're no longer doing a lot of industrial harvesting, they've either been zoned as not naturally regenerating with conifers, or not a priority for industrial harvesting. I do think many ecosystems are regenerating with more diverse species mixes than in the past. In places where we're still replanting, I don't think we're making enough progress. And so I think there are a lot of opportunities, largely guided by natural regeneration in recent wildfire areas, to allow for increased biodiversity once again. Most of those species are still present in the seed bank and across the landscape in the non-timber harvested land base, and will proliferate also from fire refugia into those recently burned areas. But we do have a need to evaluate kind of our priorities for these ecosystems longer term. And that lies more broadly with the forest industry and frankly, the policies that govern the forest industry around how we expect forests to be reintroduced after harvesting and after fire disturbance, and also free to grow standards.
Awesome. We'll move on to another one. On a post-fire area, do you see more fire-resistant species flourishing, or are you more likely to see invasive species succeed? How can forests be better managed to support the succession of fire-resistant species instead of harmful invasive ones?
Yeah, also a good question. I think it depends on what condition the forest was in when it burned, what severity it burned under, and what was present in the seed bank. Certainly, there are lots of cases where we see invasive plants coming back after fire, but we also see more fire-resistant species regenerating. I will say also many of our tree species are not strictly fire-resistant or fire-tolerant. So particularly in the interior, Douglas fir is what is in those really dense stands. But when it's suppressed, so either when it's young or just when it's small and very suppressed in the understory, it is not resistant to fire. It hasn't developed that thick bark yet. And it has a lot of those branches without foliage on them that we would consider ladder fuels. When you get a large mature interior Douglas fir that has that thick bark and that really high crown, that's a fire resistant tree. And so we have regeneration in terms of seedlings and saplings of some of these species, like Douglas fir, but also ponderosa pine or western larch. The challenge is, are they going to survive to maturity, particularly when also faced with increasing heat domes and droughts? And also, will they be able to persist across the landscape? So certainly some of these species are regenerating. Invasive species are and continue to be a challenge. And I would say our priority around invasive species management, considering the scale of these wildfire burns, is we do see a lot of invasive plants, but we do also see natural species in the seed bank. Uh, the challenge is, how do you restore a stand where you have 3,000 stems per hectare of all tiny Douglas firs and you have no large stems to retain? In those cases, it might look like more of a case of resetting the successional clock and allowing those ecosystems to come back. Or if they burn in a wildfire at high severity and the seed bank is new, considering what the consequences are of that alternative.
Yeah. And as it relates to cheatgrass, I think there's north of Kamloops or Cranbrook, there's going to be some trials with herbicide as well. Like cheatgrass, we run into a lot. It's an ongoing concern. I think in one of the states too, they're also using herbicide and then drilling, like seeding bunch grass below the layer. But that's the one, like I feel like it comes up. Cheatgrass comes up all the time for us. Okay. Oh, we got lots of water and wetlands people here too. Are methods of historic fire departure investigation such as wetland sediment coring or benthic log dendrochronology utilized or effective in BC's fire environment reconstructions?
Good question. To some extent, yes, certainly. So I will say, from the fire histories that we look at from tree rings, these are over shorter time periods relative to other methods. There have also been studies in aquatic systems using paleolimnology, which go back much further in time than our tree ring records get us over past 10,000 years or longer. In addition, I think there's a lot of opportunities in wetland ecosystems, which also evolved with fire as a role, for understanding these dynamics. I'm not aware of any literature on beaver dam analogs before or after fire, but that doesn't necessarily mean that that information doesn't exist out there. And I think that there is also relevant information to be understood about fire behavior in some of these wetter ecosystems. So in the past, we would have considered riparian areas and wetlands generally to be fairly fire resistant, particularly because of the presence of the more deciduous species mixes. Today, there's a lot of conifers in those ecosystems. And if you look at recent fire scars, we'll often see very high severity fire where fire is wicked through some of these riparian systems. And so I think in wetter systems where prescribed fire is not always appropriate, there's still a huge restoration need around the use of fire, and the role of fire adapted species, which can also be used as a fire management strategy.
Awesome. You got the Beaver Dam analog one. And we do have some analogs, I think, that are going in the Thompson in an area post-fire, and we do have some students that will be working on that. So TBD, I guess. We'll learn about it for a few years and then report out. I guess there'll be a bunch of names here. Whether organizations are currently working to return fire to the landscape within southern interior BC. So who all are you working with?
Yeah, great question also. I will say, kind of like big picture too, that the Southeast and especially the Rocky Mountain Trench has been seen as a leader in this space for a long time. And I would attribute that largely due to in the 70s and 80s, a lot of people were burning for silvicultural reasons and habitat reasons. Across the province, that largely stopped. But in the Southeast, there were a handful of very influential ecosystem restoration people, people, who kept that going up until the past couple of years, where BC Wildfire Service has started doing a lot of prescribed burning again. And that ERA program is still active. And so in particular in the Southeast, the Rocky Mountain Trench Society, very big player in the space. BC Wildfire Service leads a lot of burns in the area now, and that fire center is very active and supportive. And I would would like to kind of recognize the amount of work that's been done by individuals there, because I think they really are seen as a leader. They hosted the first TREX Prescribed Fire Training Exchange also in the province last year that I attended at ACOM, was co-hosted by the nation. Speaking of the nation, the First Nations there, several of them have prescribed burning programs, especially ACOM, but Tobacco Plains and Akiskanak are also developing prescribed fire programs, and there was a prescribed burn down at Yakanuki last year as well. City of Cranbrook and City of Kimberley also have large prescribed fire programs. City of Cranbrook, especially at their airport location, has had probably over a decade at least of continuous burns based on prevention of hazard and the importance of that airport as critical infrastructure. The Nature Conservancy in that area burns, provincial parks burn, the national parks burn. Essentially, it's most land managers are kind of on board with the fire program, and increasingly we're also getting interest from ranchers with range tenures to burn. And so, there's a large number of players. BC Wildfire Service, I would say, is involved in most of these fire operations, but increasingly also there's capacity internally. For example, at the City of Cranbrook, their staff are trained and now manage the majority of these prescribed fire operations, with BC Wildfire Service there supporting, which also allows them to free up staff for other burns happening on the same day in other parts of the district. So
awesome. So it takes a big team is the answer, and there's a whole pile of organizations, NGOs, funding agencies, both provincial and federal, and then a lot of communities, a lot of First Nations communities, Indigenous communities that are saying, hey, we want fire back here, let's make it happen. Do you have any advice for First Nations evaluating the fire risk of their forests?
Yeah, I would say, especially from a First Nations perspective, there's often challenges around capacity. I've worked quite a bit with First Nations Emergency Services Society, or FNS, and they're great in terms of availability of resources for training, for identifying wildfire risk, kind of fuel management pieces, different supports for data collection that are also compliant with ownership, control, access, and possession, or protection of that data, data sovereignty. More broadly, I would say, there's a lot of tools out there now that allow you to evaluate wildfire risk that have, I would say, varying degrees of accuracy or representation. And a lot of them are for sale. And so one of my big cautions, I guess, is places where I perceive that industry or private corporations are trying to take advantage of communities that are exposed or at risk. So I would certainly encourage anyone working for a nation who's very likely has limited capacity and is working kind of as a generalist across a lot of land management jurisdictions to reach out to organizations like FNS to get support for how to navigate these types of things, especially off reserve, kind of more broadly across Crown land, although certainly lots of tools available for on reserve projects as well. The biggest piece, I would say, is trying to understand your fuels. And there is just not a lot of good data out there on understanding fuels. And so the best place to start is with your own understanding of your landscape. And especially anyone who is from that nation who has worked in wildland firefighting typically has a really good understanding of where your problem fuels are going to be, where your weather patterns are going to come from, and what their priorities would be for response.
Thanks. We'll go for a couple more. I told you it'll only be 15 minutes, and I think we're closer to a half hour. People went from no questions to tons. Do you think there have been any differences in how First Nations manage fire in similar ecological landscapes?
Certainly. Yeah. So, I'm not an expert on cultural fire. I'm not an Indigenous person, and I don't claim to have expertise specifically in cultural burning. But I think we're very confident that different nations burned in the past for different reasons and in different places. So I think, the most logical way to trace that back is that there's different species in different places with different adaptations, even if the climate zone is different, because we have such strong terrain and geographical separation of ecosystems. Similarly, their biodiversity and their communities evolve differently with fire in different ways. And so I'm sure there is a very wide range of things that we don't even know about that have never been documented in Western science, but that exist in cultural knowledge of how fire has been used in different ways to manage for basket weaving, different types of basket materials, different food products like different root crops and berries, and wildlife habitat and migratory corridors. I'm sure there's countless examples of intersections between wildfire management for different cultural values, and also how that relates to different Indigenous languages and cultural practices. I don't have a lot of good examples off the top of my head of different ecosystems managed in different ways. I think especially because I've mostly worked in this one system across Ktunaxa territory, and so those are kind of the systems I'm more familiar with. And even there, I would say there's not a lot that's documented in terms of publicly available information of the association between cultural resources and fire.
Thank you. Okay, here's a little bit more technical. In the BC interior, you discussed thermal cover as being important for wildlife species and with increasing importance in the face of climate change. Wondering how a combination of thinning and restoration fires can maintain and continue this important habitat supply in the face of AACs and timber supply analysis chasing these dense pine stands that are often difficult to locate and where timber supply analysis is based on so many assumptions. So I think the root of it is, how does thinning and restoration work on habitat supply and in particular thermal cover?
Yeah, so also a great question. One of my colleagues, Georgina Preston, recently completed her master's where she was specifically looking at fuel treatments in mule deer winter range and old growth management areas in the Caribou with SXFN, which is Stweckum First Nation, which is surrounded by these legal objectives, old growth management areas and mule deer winter range, where the community is often challenged by or restricted from doing treatments in these areas for fuel reduction reasons. She specifically did modeling of wildfire potential in these different jurisdictions. And in the mule deer winter range, she found that fuel treatments that would have been compliant with the restrictions of mule deer winter range would not have sufficiently reduced wildfire risk to protect the community. In addition, she also looked into additional research on whether the forest structure that was actually there would have been supporting mule deer winter range in terms of forage and thermal cover, and found that it also was not meeting objectives from a habitat perspective. And so I think a lot of the times our existing policies are getting in the way of the thing that they are trying to protect, and at the same time creating a whole suite of new problems for us. That's not to say that we shouldn't be managing for ungulate habitat on the landscape, but that I think there's opportunities to be a bit more intentional, especially around First Nations communities that are trying to manage for or enact their own sovereignty over those values, and where they often also care about ungulates and their ability to harvest ungulates. But there are more opportunities to align wildlife habitat management and wildfire risk reduction than I think we realize. And this is something I've also been talking a lot about with wildlife biologists, especially in the Southeast and in relation to that project with Tobacco Plains, around where those values align and places where we can create more food for ungulates, reduce wildfire risk, and reduce the likelihood of invasive species coming in. I think there's more win-wins out there than we realize, especially based on current policy and legislation, and also based on, to be honest, the lack of quality data we have for a lot of these ecosystems where these management decisions were made without someone actually going there and looking at it and making that decision.
And we often, I feel like we run into this. We start at this place like ER looks like this. This is what fire looked like on this landscape. This is what this landscape looked like 150 years ago. And when we start to narrow down, then it's like, well, what about this bird will be displaced if we burn sagebrush here, or this species at risk, or this ungulate will be affected. And so we lose the plot, we lose the big picture, and we get down to these very small things about displacing individual species or individual animals. And you get to a point where you just say no when you kind of narrow your scope down. So I feel like sometimes we get way, really caught up in the details. And if you drill right down, your fire is going to affect something on the landscape, right? There's going to be something. And so, if we're talking at the, an inch into the ground, we're never going to get to fire if we don't see the big picture. And I feel like that's one of the examples. There's a lot of challenges out there where we needle away to say no, as opposed to saying, this is what the landscape should look like. We know it's generally going to be good for wildlife. We know it's what it used to look like. Let's get there. I think that's kind of the way we got to turn our minds. From a broad, oh, this is going to be a hard one. From a broad generalization, what would the long-term financial and staff requirements be to return fire to the landscape in the East Kootenays?
That is a big question. I think one of the biggest challenges right now from a fuel management perspective is that there are very few dedicated and secure positions. Essentially, there isn't a workforce or an industry to support those types of positions. And I think there's huge opportunity. This is something I've also spent a lot of time working with Finesse on for local communities and especially for First Nations to manage the risk around their communities with year-round secure employment positions, where you have people responding locally to wildfires in the summer and then doing fuel management in the winter and doing prescribed and cultural burning in the spring and fall. Seasonally, there is a year-round calendar of wildfire management, traditionally from Indigenous fire use and land stewardship. And there is an opportunity under a kind of contemporary framework and also a modern bioeconomic framework around the need to manage fiber that comes out of these treatments that often gets burned in piles right now, which has huge consequences also from a carbon perspective of what do we do with what's left over. And there's huge opportunities to align that with changes and transitions in the forest industry, mill closures in particular, and being able to kind of decentralize our forest economy and make use of this fiber, smaller stem fiber, alternative wood products that are coming out of these forests. In terms of the financial commitment to that, I think we've seen provincial investment, and certainly in the past couple of months, it's become more challenging across jurisdictions financially. But we've been pushing for a long time for the need for programs. We can't continue funding things as a one-off treatment, a one-off burn. We need secure funding so that people can have permanent positions in order to manage not just wildfire risk in communities, but across the broader landscape. And we need large independent funding from suppression budgets. We can ask BC Wildfire Service, we can ask the land manager across a lot of the landscape to support these initiatives, but fundamentally their jurisdiction is to respond to wildfires. And so we need workforces that can do all of this other work, managing fuels, proactive management, recovery and response, independent from suppression response. And that will also require a lot of growth of capacity, a lot of training of people to work in these spaces, and the creation of jobs and positions in order to be able to do so. But there's huge opportunity with the way the direction the forest industry has gone over the past 15 years and the need for innovation. And so I think there's a lot of intersections, especially in the First Nations forestry space, to be able to make use of that.
It's a good question, and it's a hard answer because it depends again on what your objectives are. If it's just to keep communities secure, it's still expensive. But I think in the East Kootenays, like Don Gayton's old paper, he was estimating they were losing 3,000 hectares per year from 1952 to 1990 something. So we can take that forward to now. So let's just say 80 years at 3,000 hectares per year. Right? And at, let's say, $1,000 per hectare, 500 if it's good. I mean, it's millions and millions and millions of dollars. I think the answer is you got to get on it, prioritize where you're going to do it for overlapping values. And the piece about fire, I think, is like anything else. Once we start getting good at it, we can start scaling up and start doing bigger burns and build confidence and capacity and skills. So, it's a loaded question. It's like the problem is billions of dollars worth in BC, but also if we look at the fire season from 2023 and we look at suppression costs plus insurance costs, fire is costing us billions of dollars per year anyways as taxpayers. In your research, have you identified much data from research projects that illustrates the success of cultural and prescribed burning practices in relation to wildlife and mitigation? This information can be valuable in reiterating the necessity of this funding for these projects.
Yeah, so in terms of the benefits of prescribed and cultural burning, for especially prescribed burning for mitigation, certainly there's been increasing number of students coming out of Laurie Daniels' lab looking at the efficacy and effectiveness of fuel treatments from a wildfire mitigation perspective. And we're expanding that project right now with partnerships across the province in a range of different ecosystems to look at how effective fuel treatments that are being used are and when they interact with wildfires. as well as how effective we expect them to be. In terms of the intersections with wildlife, I think that work is a lot newer. It's challenging to study field treatments fundamentally because you have to get in there before the treatment happens, ideally, and then you have to get in there again after the treatment happens. And so a lot of that work has only really been established in the past couple years. But now that we're establishing some of these plots, there are also opportunities to align plot locations with wildlife cameras, for example, or in the Southeast, we're also working with collard data. And so that's one of the things we're hoping to find out of that study. I think both from the research group at UBC Forestry and then our work at UBC Okanagan and other researchers across the province will begin to see more of that work emerge. But I would say the interactions between wildfire treatments and their effectiveness and wildlife response is something that's still very new from a research perspective. And so hopefully we'll see more research coming out of that in the next couple of years.
Yeah, that's one of our biggest limitations. I mean, around wildfires, we definitely have data that shows demographic change, growth rates. You can see it through hunter harvest. I mean, that's a big part of the, the motivation of some of these big fires, like the Okanagan Mountain Park Fire. We saw wildlife populations absolutely explode, and on the flip side, we're now seeing them shrink like rapidly because of fire suppression, because we didn't get in there and deal with pine trees. One of the biggest questions for the ungulate folks is like, at what size? Right? That's the question that we don't have an answer for, but as you say, we're putting cameras out in all of our treatment areas now, and then Dr. Daniels has got students doing veg plots, so we'll put it together slowly, I guess. In our world, typically bigger is better. Okay, last one for tonight. I'm currently a student and a seasonal firefighter, very interested, wondering what programs you can study these things or what your schooling look like. We touched on that a little bit at the beginning, but I guess if people want more knowledge, what courses or programs would you recommend if they're interested in wildfire or wildfire and wildlife?
Yeah, great question. So in terms of what my schooling looked like, I, in the kindest way possible, would not recommend a PhD to most people unless you really like spending a lot of time staring at a screen. But there are a lot of new programs that are being developed across the province right now. There is a huge need, huge gap for sure, for kind of wildfire training and education, especially from a practitioner perspective. There's pathways that exist for people like me that want to be researchers, but we need a lot more training available for people who want to go out and actually do something about it instead of just studying it. One of the things I would recommend is that there's some online courses available through the University of Idaho, including RX310, their Introduction to Fire Effects course that's fairly low cost and that can help kind of provide an introductory perspective on more of the fire ecology pieces. There's also a wildland fire micro-credential available at UBC Okanagan now. And I know both at UBC Okanagan as well as at TRU, there's currently programs being developed around wildfire response and management, as well as fire ecology and kind of the more proactive pieces, prescribed fire. At both institutions, I know those are currently in development, and I would expect those to be available to students in the next couple of years. But if you're interested in research, many of us, including myself and Lori Daniels and other researchers across the province, also train undergraduate and graduate students through our research labs. And much of this research that's presented, including my work, my colleagues' work, is led by graduate students, master's and PhD students. And so there are a number of opportunities available as well in that space.
Awesome. It's great to see because, in the past, everybody got sent to University of Idaho if they wanted to have anything to do with fire control burns up here. So it's awesome to see UBC developing some programming. We did have a number of requests for your presentation. So just to let everybody know, we'll get a copy of the presentation. We can put it on our website. We will have the video will be up on our YouTube channel. It's up on Facebook Live. If you have questions, feel free to reach out to Dr. Barron or to myself or to my team, and we'll do whatever we can to help support you. So thank you, everyone, for coming on, and thanks, Dr. Barron. It was awesome, really good job. Lots of engaged folks. That's it for tonight. We went way over, so I guess I owe you now, Dr. Barron, because I told you it would just be 15 minutes of Q&A. So the next time you're in Kelowna, I'll buy a coffee. And for everyone else, we upcoming webinars, we're going to have one on invasive pigs, and also on CWD, a paper that was recently published out of Wyoming that talked about CWD management and what you can do. Of course, BC, we're in a tough situation now that we have chronic wasting disease, but it's a bit of an opportunity to kind of get ahead of the curve as it relates to CWD management and try to do our best to avoid similar situations to other jurisdictions. So thank you all for coming out. Be sure to check out our member update and our social media feed for future webinars. And Dr. Barron, thank you again. Great job.
Thanks for having me.
All right. And thanks to our team, Philippe, and our marketing communications team as well. I hope everyone has a great night.